We are given this diagram, which consists of a cylinder and a hemisphere at the top. The cylinder has a radius of r and a height of h. So we have to express the total surface area A as 5 pi times 144 over r plus r squared over 3. We have to show this. But before that, we have to express h in terms of r first. So we are given a total volume is 360 pi centimeter cube. So volume of a cylinder is pi r square h, which is the base area times height. So base area is pi r square times height h. Volume of hemisphere is half times 4 over 3 pi r cube equals 2 over 3 pi r cube. So total volume is pi r square h plus 2 over 3 pi r cube equals to 360 pi. We divide pi on both sides, we get r square h plus 2 over 3 r cube equals 360. So we express h in terms of r equals 360 minus 2 over 3 r cube here by r square. We get 360 over r square minus 2 over 3r. So the total surface area of the cylinder is actually pi r square, which is the base, and 2 pi r h, which is the side. So pi r square plus 2 pi r h we substitute as 360 over r square minus 2 over 3r. We expand, we get pi r square plus 720 pi over r minus 4 over 3 pi r square. We combine the pi r square together, we get 720 pi over r minus pi r square over 3. The surface area of hemisphere is half times 4 pi r square equals 2 pi r square. Therefore, the total surface area is 2 pi r square, which is surface area of hemisphere, plus 720 pi over r minus pi r square over 3, which is surface area cylinder. We simplify, we get 720 pi over r plus 5 pi r square over 3. Factorize the similar 5 pi out, we get 5 pi times 144 over r plus r square over 3, which is the area that we are supposed to prove. So our part I is dA over dr is actually a stationary value. So we have to differentiate differentiate A, we get dA over dr, and then when we equate this dA dr equals 0, we can find the value of r. So dA over dr is obtained when you differentiate 5 pi 144 over r plus r square 3. We leave the 5 pi alone, we differentiate 144 over r plus r square 3. So when you differentiate 144 over r is equivalent to differentiating 144 times r to the power of minus 1. We bring down the power negative 1 and minus 1 to the power, you get negative 144 over r squared plus 2r over 3. It's obtained by bringing down the power 2 and minus 1 to the power, we get 2r over 3. So we equate to dA over dr equals 0. So 5 pi times negative 144 over r squared plus 2r over 3 equals 0. So negative 144 over r squared plus 2r over 3 equals 0. So 144 r squared equals 2r over 3. We cross multiply. 432 equals 2r cubed. 216 equals r cubed. R equals 6 cm. For part 2, to find the overall height of the body when A has stationary value. So we have to sub in a value of r, which we have found to be 6, into the equation which we have found earlier for h. So h equals 360 over r squared minus 2 over 3r. So h equals to 360 minus 6 squared minus 2 over 3 times 6 equals 10 minus 4 equals 6 cm. So to find a stationary value of A, which means to find a value of A when r equals 6. So A equals 5 pi times 144 over 6 plus 6 squared over 3 equals 565.49 in 3xl equals 565 centimeters squared. To determine whether the stationary value of A is maximum or minimum, we have to further differentiate dA over dr. We get d square A over dr square. So when further differentiate the equation, which is this equation, so when differentiate negative 1444 over r square, it's actually equivalent to negative 144 r to the power minus 2. So we bring down r to the power minus 2 and minus 1 to the power, we get to 144 over r cubed. And when differentiate 2r over 3, we get 2 over 3. So it means 6. So seeing this d squared over dr squared, we can see that it's more than 0 for any value of r. So when it submits 6, it's definitely be more than 0. So since it's greater than 0, it shows that it's a minimum. Therefore, stationary value of a is a minimum.